Welcome everyone to this another interesting topic in our series of lectures on different type of technologies and workflows that we use in oil and gas exploration, production, as well as the abandonment. Today we are going to talk about the wireline technology. This is not a new technology; it has been around for almost a century now, um, but it is one of the crucial pieces of technology that is required whenever we are exploring or producing oil and gas. So, what we are going to talk about today is primarily what is wireline, why it is called wireline. We're going to talk about logging operations, different type of wire lines like slick line and braided lines. We are going to talk about different type of wireline tools. I'm just going to give you a quick overview about what type of tools are used. We are not going to go very deep into the types of tools and their physics because their physics can become very complicated. Uh, and we're going to talk about different type of wireline units. I'm going to show you a lot of pictures of these units being operated out in the field, and then how pressure control is important during the wireline operation. And we are going to conclude on what we have learned in this presentation at the end of this session. So, what is wireline? Wireline is a term that has very different meanings across the industry. But in oil and gas industry, the wireline actually means the cabling technology that is used by the operators of oil and gas wells to lower different type of mechanical, electrical, electromechanical, and electronic equipment into the well for the purpose of well intervention, reservoir evaluation, and pipe recovery. What do I mean by well intervention and reservoir evaluation? Well intervention is primarily to perform a different type of mechanical operation downhole, and reservoir evaluation is primarily to determine the physical and chemical aspects of your reservoir. So this is what a typical wireline setup would look like. We have a wireline unit right over here. There are a bunch of cables that you can see over here, but there is one cable that is going through the wireline unit in through a sheave into the rig, and through the rig it's going downhole into the well. And this cable can be either electrical cable or a mechanical cable. We are going to talk about the differentiation between the two cables in the coming slides. So what is logging? So logging, when we talk about wireline, the next term that you're going to hear about is wireline logs and logging operation. Logging essentially is an operation in which we take physical quantities in and around the well versus time or depth or both. That means different type of physical quantities are measured across depths of the well or across the time. The term log is usually used in terms of recording or taking a note of those measurements as you go deeper into the well. The wireline logs are usually taken downhole and then they are transmitted through the wireline cable, which is electrical cable, to the surface. And on the surface, where you have that wireline unit, at the unit they are recorded, and they can be also transmitted through VSAT to the office or the company setup where they can actually take that measurement and then start doing their evaluations and analysis. Why do we log? There is just one purpose of performing a log, and that is to help the customers to produce oil and gas more efficiently. And the reason for that is that everything downhole is kind of a black box, right? If you don't have certain measurement tools, you don't know at what depth your oil and gas reservoirs are. Or if there are oil and gas reservoirs downhole, what is the quantity of oil and gas present over there? So to get those answers, we need to log. And for logging, we need the wireline. So the first wireline log was done by Marcel Schlumberger back in 1930s. Schlumberger brothers Conrad and Marcel Schlumberger were the first one who invented electrical resistivity tools that can perform a wireline logging. So essentially, the two brothers came together formed a company
from that place again,
which is considered one of the biggest oil field service providers now, and they were the first ones
come
to.
inside. Sit down here.
Ladies and gentlemen, please. This is a request that I made very often. Sometimes I forget to turn off all the microphones. Let me do that right at this time. Since I did forget, I'm gonna turn your microphone on in a second, Hassaan Ali. But I would like to ask everybody to please refrain from speaking or having any type of conversation or talk or noise background, because this is very disruptive to the process of our class. So please, I know you cannot do that now since I just muted all microphones, but every time I forget or anybody else forgets, please manage to yourselves turn off your microphones, allowing our presenter to go with the flow of his or her presentation. So please go ahead now, Hassaan Ali. Your mic is on.
Thank you, Prof. So the two brothers came together, formed a company which is considered one of the biggest oil field service providers and technology company now. But they were the first ones who developed the wireline technology and developed the tools that are used to determine reservoir evaluation and to perform reservoir intervention as of today. So to expand on the fact that we want to do electrical logging to produce oil and gas more effectively, there are four basic reasons. If we try to dissect it a little bit further, why we do logging. Number one, we want to identify hydrocarbons. We want to identify where the hydrocarbons are located. We want to determine their type. If it's a heavy oil, it's a medium oil. If it's a light oil, if there is how much gas is present, and what is the volume of that hydrocarbon that is present. We want to determine what type of fluids will flow. That means if we do complete the well, what would be the different type of fluids that will be flowing through the well, and at what rate we want to optimize the well construction and reservoir production. So we want to know different type of parameters. For example, one of the parameters that we want to know when we are doing the logging is to understand at what depth do we need to land our tubing. That means at what depth our pay zones are, at what depths the reservoir is producing. All of that information is usually gathered through a wireline log. How do we log? There are basically four big systems that are required for doing a wireline logging operation. Number one is wireline unit, logging unit. Second one is wireline cable that is going from the unit to the downhole tool. Then there is a logging tool that is performing all the measurements, and then wireline acquisition system, which is the data acquisition system that is located inside the wireline unit. Two types of wirelines. When we talk about wirelines or the cable that is running between the wireline acquisition unit and the downhole logging tool, there are two types of cables that we talk about. The first one is called slick line. The slick line is essentially a very thin cable that is used to deliver and retrieve tool downhole. It can be used to place and recover well bore equipment such as plugs, different type of electrical gauges, valves. They can be also used for different type of well intervention tools like kickover tools for replacing gas lift valves. Essentially, this cable is a non-electric cable. That means there is no electricity or no telemetry that is being passed through the slick line cable. It is just a metal cable that is running between the wireline unit and the downhole tool. Now, since this is a non-electrical cable, it cannot be used to operate electromechanical or electronics downhole. It can be only used to operate mechanical tools. For example, to set up plugs, to set up gauges, to set up gas lift valves, and different type of pure mechanical tools. They can also be used to adjust valves downhole, different type of wireline or the slickline retrievable valves. They can be used to open sleeves downhole to control the flow of the reservoirs, to control the flow of the wellbore fluid into the tubing. The second type of cable is called a braided line. Essentially, when we are performing a wireline logging operation, the logging operation utilizes a braided line. Now, braided line is essentially an electrical cable that has been surrounded by different type of jackets to keep it secured. The braided line consists of an inner core of wire, which is right over here, the conductor, which is right over here, and there are different other conductors which are surrounding the main conductor. All of these cables are performing some sort of electrical operation. Either they are transmitting data or either they are retrieving data from downhole. So braided line is also normally referred to as electric line. And this electric line provides a pathway of electrical telemetry or communication between the surface and the downhole logging unit or the logging tool. So the last one which we are going to talk about is the wireline tools. Essentially, wireline tools are very, very, very specific, very specialized, very complicated tools which can be used to perform different type of measurement operations downhole. These are usually lowered through the electrical line into the wellbore, and they are located at the end of the wireline cable, and they perform different particular services. For example, one particular tool can perform evaluation of the rock properties. One of the tools can actually determine resistivity of the electrical formation of the formation. They can be used to locate the casing collars. There are different type of pressure tools that can be used to measure formation pressures, and they can be used to determine the porosity of the reservoir or the formation, and to identify what type of fluid is present, what is the API of that fluid, and they can be also used to recover or do the sample recovery from downhole. So they can actually do the coring operation as well. Some types of wireline tools are nuclear tools. They have different type of nuclear sources that can be used to shoot nuclear, essentially neutrons into the reservoir, get them back, and determine the formation properties. There are electrical resistivity tools. There are different type of sonic and ultrasonic tools, magnetic resonance tools, and then different type of seismic tools and cased hole electric lines, which can be used to determine different type of formation properties. So wireline throughout the life cycle of the well. This is a bird's eye view of where different type of wireline services are located and what is the importance of those services across the whole life cycle of the well. And you can see right over here, right? This is the entire life cycle of the well. It starts with the drilling operation, the completion operation, the pumping operation where the hydraulic fracking is performed, the intervention operation across the well, the life cycle of the well, and finally the abandonment, where the well is capped, it is pumped with cement, the topside surface facilities are removed, and then remediation effort is performed, and the well is effectively, it disappears from the surface. So you can see, so all the way from exploration, well construction, completion, production, abandonment, wireline performs its individual specific operation across each individual life cycle of the well. So there are we actually divide them into two types of services. The first are called evaluation services. And the second one is called intervention services. Evaluation services are primarily what we historically or legacy, in the legacy operations, they used to be called open hole services. This type of operations effectively measure and analyze the formation and reservoir. Majority of these services are usually run in open hole configuration. That means before we set and run the production casing or completion. So effectively during the drilling operations and construction operation. Then intervention services are also, they used to be called cased hole services. Effectively, these are the services that we perform once the well has been constructed. That means your casing has been set, your tubing has been run, your liner has been set. And these contains huge array of services all the way from well intervention, that means setting plugs, opening up valves, opening up sleeves, and a deployment of perforating guns where the guns are actually deployed into the well. They are shot, creating these different type of holes on the production tubing so that we can actually produce. And then also for the production survey platforms, that means uh, the intervention services, you can actually determine how much production you are getting from the well as well. So a bit deeper into the cased hole services and open hole services. Open hole services are basically evaluation services. These are done during the drilling operations, when the well is being drilled and being constructed. And this is to get different type of reservoir characterizations like petrophysics, geology, geomechanics, and reservoir testing. Um, and usually the tools that are used for the open hole services are different from the tools that are used for the cased hole services. So cased hole services, we primarily do it when the well has been constructed, your casing has been deployed, your liner has been run. So effectively, the difference between the two services, what you need to understand is open hole services are run during the drilling operations, cased hole services are run during the production operations. That means that the tools that are used for both of these services are slightly different. Over here on this picture, you can see a cross-sectional view or the high-level view of what a wireline operation actually entails. We have the wireline unit right over here. We have sheave fields over here, and the electric line is running all the way from the wireline unit through the sheave wheels, from the derrick of the floor into the downhole tool. So this is the downhole tool. This downhole tool can be combination of different wireline tools. We're going to talk about different type of combinations in the coming slides. This is what a land wireline unit actually looks like. Similar to the offshore unit, we have the wireline acquisition truck right over here. You can see the truck. There is an outline of a truck, and inside that truck there are a couple of things that are located. There is acquisition system, which is right over here. It requires a bunch of reading equipment, measuring equipment, data storage, as well as computers. And then we have a cable drum on which the wireline cable is being um, uh, like effectively being run. And then there is a special type of assembly, which is measuring essentially two things. One is how much cable have you used, and the amount of cable that you are using will determine the depth that you are being run. And then this assembly also entails what we call a cable tensioning device. So the cable tensioning device is measuring the tension of the cable because the tape cable has certain safe working load. That means it cannot go beyond certain weight capacity. This device is also measuring how much load we are putting on the cable. Then this is that logging cable or the wire line, and this is the logging tool. This logging tool has a bunch of electronics and mechanical systems that are inside that tool that can perform certain operations, depending upon the requirement of the application. This is what we call an offshore logging unit, very much similar to the land logging unit. One of the few things is that it has its own standalone unit engine. Um, you have your cable drum, which is very much present in a land unit as well. Then we have wireline cable. PSAT is there for the real-time data transmission. And there are a bunch of people over here. Winchman is here to effectively run the winch. That means coiling or uncoiling operations of your cable drums. And then you have acquisition engineer and the reservoir engineer right over here, and the acquisition unit as well.
Mm.
This is an example of a wireline, a land wireline unit. You can see a couple of systems over here. This is the cab in which the acquisition system is being located, and this is the VSAT through which the data transmission can be done all the way from on-site to the technology center. This is the wireline unit. What you can see is over the acquisition system is located inside the cab, and then your cable drum is located right over here. This is the view from inside the land acquisition unit. So you are sitting on the winchman seat, and you are seeing the wireline drum. This is the device that is measuring the cable tension, and it is also measuring the depth of the well. Effectively, it is using how much cable you have used, and from there it is correlating it to the depth of the well. And this is your rig floor. This is your derrick, and your wireline cable is being run through this device, going through the sheave into the drilling rig. An example of the wireline logging tools. These are the two tools. I'm going to talk about the OBMI tool. This is effectively, these are the resistivity pads. This tool is used to determine the resistivity of the rock formation. The tool on the right-hand side is what we called a dynamic tester. This tool is used to take samples of the reservoir formations, and it can be run as a combination of different other units as well. Acquisition system is effectively a telemetry tool that is acquiring data from the wireline logging tool that is downhole. The tool will transmit that data through the logging cable or the electric line cable into the interface. From the interface, it will go into the processor and the display. From the processor and the display, it can be used to print either the results directly onto the logging unit printer, or it can be used to transmit it through the VSAT into the technology center. These are the two wireline logging charts that you can see. There is a linear display, which is right over here, and then there's a logarithmic display. The difference between the linear display and logarithmic display is that logarithmic displays usually it is power to the factor. That means it will be used to enhance the results, while the linear display is 1-to-1 ratio. So what do the clients want? Effectively, the clients want to know where the oil is and how much oil is in place. And there's a formula for it, whereas that the oil in place is effectively the volume of your reservoir multiplied by porosity of your reservoir multiplied by saturation. The porosity is effectively how much fluid can rock hold. Every rock have the different porosity value. That means there are some rocks with high porosity values and there are some rocks with lower porosity values. The rocks with the higher porosity value, this is something which you are looking for. You want to have a rock with higher porosity value because that will tell you that it is holding a lot of oil and gas in it. The second thing is saturation. That means how much fluid is present in that pore space. And effectively, it is a factor of amount of fluid and the pore space in percentage. This saturation is effectively measured in two ways. One is hydrocarbon saturation, and the other one is water saturation. You want higher hydrocarbon saturation and lower water saturation. And then the BO, or the saturation factor over here, is oil formation volume factor. There are different type of charts that can be used to determine, based on the log type, it can be used to determine the BO factor as well. So conveyance method, there are effectively 4 types of conveyance method that are used during the wireline operation. The conveyance means how you are pushing that tool from the surface all the way to the downhole. The first is wireline. That means by virtue of gravity. The issue with that is that it can be limited by the borehole profile in the deviation. That means Nowadays, the wells are not drilled vertically. They go vertically to a depth, and then they go at an incline. Now, the problem with that incline, or that do we call it a dogleg severity or the deviation? The issue with that deviation is that now your gravity is not very effective in pushing your fluid or pushing your tool all the way to the depth you want, because with the incline, with the deviation, the gravity won't be able to push it. Then you need different other methods of conveyance. One of them is called um, through bit logging or the drill pipe logging. That means you're pushing your logging tools through the drill pipe, or the drill pipe is pushing those tools. This is slow, this is very expensive, and this is not suitable for the production logging. The reason for that is for the production logging, you cannot move the rig to the well because the well has been already drilled. Moving a rig can become a very difficult proposition. It can be used for the open hole logging, but again, it is slow and it is expensive. The third method is what we called a coil tubing. That means a tubing which is much smaller than the casing, and the tubing, the production tubing itself, is pumped. And then we have a coil tubing unit right over here. And effectively, we push the tool downhole. You can see two units over here. One of them is a coil tubing unit, and the other one is the wireline unit. The wireline unit is connected through the cable to the downhole tool, while the coil tubing unit is effectively pushing high pressure water uh, to push that fluid to the depth you want. So coil tubing can be used to push that fluid to the depth you want as well. But one of the downside is that it can use considerable amount of equipment, personnel, and time. So it becomes very expensive. The third one is what we called a wireline tractor. This is that tractor. Effectively, this is a mechanical tool that can actually run through the deviations, and it can convey the tool to the depth you want. Now, we have talked about different type of wireline tools. We have talked about the different type of slickline units, different type of cables. We have talked about slickline cable. We have talked about the braided or the electric line cable. Now, I'm going to quickly talk about the surface seismic operation. Surface seismic operation sometimes is also characterized as part of the wireline operation. Effectively, surface seismic operation is we are trying to determine, even before drilling any hole, before running any wireline, we are trying to determine where should we look for oil and gas, where the oil and gas is located. Earth is huge. How we can determine which area to target and which area not to target. So for that, we use what we call seismic operations. For the seismics, for the onshore or the land seismic operations, we use different type of methods. One of the methods is what we call using explosives. The issue with the explosives is that for that you need some sort of drilling. Then explosives have health, safety, and environmental aspect of it, as well as especially the safety aspect of it. You cannot transport these explosives anywhere or any other, like there are restrictions in explosive transportation across the globe, so it can result in some sort of issues. And then there are environmental concerns for the groundwater as well. And last but not the least, one of the downsides of using explosives for the seismic operations is that the productivity is much lower. The second operation that we use is what we called big seismic vibrators. These are big trucks on which big vibrators are actually mounted. These will attach to the ground, and then they will generate these vibrations into the ground. And what will happen is that these vibrations will travel into the ground. And whenever there is a difference in the formation properties, they will be reflected back, depending upon how much your properties are changing. And that data is acquired, it is analyzed, and it can be used to determine where there are formations or reservoirs are located with oil and gas prospects. The issue with Some of the downsides of these seismic operations using vibrators is that it's not suitable for rough terrain. Obviously, with the rough terrain, you won't be able to get the trucks to those locations. They're not suitable for wet terrains, and they have high vibration maintenance cost because these units are huge. They are mechanically complex, so they can be difficult to maintain. Similarly, for like the land seismic operation, we have the marine seismic operation as well. And in marine seismic operations, we use air guns. These air guns shoot very high pressured pockets of air into the water body, and then they are reflected back from the reservoir, and then you can acquire that data. And then similar to the how in the land seismic operation you are using vibrator units, we are using air guns in the marine seismic operations. Issue with the marine seismic operations using air gun is that it's not very suitable for the shallow water. And with the presence of mud and slate on the ocean floor, the signature deteriorates. And obviously, there is a concern for environmental related to the marine life. This is a common schematic of a marine seismic operation. There is a boat which is actually towing through a cable, many hydrophones. It has one cable which is connected with the hydrophones. There is one cable which is connected to the air guns. The air guns are shooting high pressured pneumatic waves into the ocean. These waves get deflected. You can see the deflection from the seabed floor. You can see the deflection from different reservoir layers, and these will be acquired by the hydrophones. These hydrophones will determine the strength of the signal, and based on that, they will analyze and they will try to determine what is present below the seabed and sedimentary layers. This is what we call a 2D and 3D seismic operation. In 2D seismic operation, was just one array of hydrophones. In the 3D seismic operation, there are multiple arrays of hydrophones. So seismic data can give you a lot of information. In its standalone, it can give you structural information and as well as stratigraphic information of the reservoir. For example, what you can see over here is the seismic operation can actually determine a large tectonic fault as well. But when it is overlapped and calibrated with other data that you are acquiring through wireline system, it can actually give you information about the fluid movement. It can tell you where the fluid is moving. It can give you the lithology prediction. Lithology is effectively determining physical and chemical properties of the rocks. And it can also give you information about rock engineering reservoir properties. Now, talking about the porosity. Porosity is effectively how much fluid a rock can hold. It is a factor of empty space divided by the total volume of the rock. That means whatever the volume of your rock is, and the empty spaces between the rocks. There are two types of porosities. Primary porosity is inherent property of the rock. It exists in the rock formation when it is first formed. The secondary porosity is effectively produced by the action of formation waters, tectonic operations, tectonic forces, because they can actually change the porosity of the rock as well once it is deposited. So effective porosity is, there are two types of porosities. One is called effective porosity, which is how much well-connected these pores are, because the more well-connected they are, the more easy for the liquid oil and gas to flow through these. Ineffective porosity is that the space is created between the rocks, but these porosities are not connected. That means the liquid cannot find its path through. It will just get stuck in the holes. So for us to have a very effective flow, we want to have a more higher effective porosity and less ineffective porosity. Now, we were talking about the wireline tools. We talked about the resistivity tools, we talked about the sonic, ultrasonic tools. I gave you an overview of what type of different physics these tools uses. In this slide, what I'm trying to highlight is that we can actually combine these tools together in one tool string. So once you combine them together, they become a tool string or BHA, bottom hole assembly. And these tools can combine together, and in one single operation, you can take multiple measurements with just one run. For example, this is what we call a triple combo. This has AGNS, which is highly integrated gamma ray neutron sonde. And then we have high resolution mechanical sonde, and then we have azimuthal lateral log sonde. Essentially, what we are doing is that all three of these tools, AGNS, HRMS, and HALS, are effectively doing different type of measurements. And when you are doing one wireline run, that means you are lowering your tool one time. You are doing all these measurements in that one particular run. So you don't have to run all of these tools individually. You can just run them as a combo. Pressure control during wireline is a very important thing because loss of pressure control can result in a blowout. So pressure control during the wireline operation is intended to contain the pressure that is originating from the wellbore inside the wellbore. We don't want it to have an uncontrolled exposure to the surface. So during the open hole electrical operations, that means during the reservoir evaluation and drilling phase, there can result a well kick. That means there can result a sudden influx of hydrocarbons into the wellbore. So during the cased hole operations, we have to be cognizant of the fact that your well barriers need to be present. That means your BOP need to be present. You need to have all the controls in place so that that well kick does not result in a well blowout. The second thing in pressure control during the wireline operation is pressure rating of your equipment, because you need to determine what is the maximum pressure that you will encounter during your operation. And based on that, you need to make sure that the pressure rating of your equipment conforms to the maximum pressure that you can experience. So usually the normal rating for the wireline equipment is 5K, 10K, and 15K. This is usually the categorization of pressure rating of the equipment. What I'm trying to say is that, for example, if you have a reservoir that can maximum produce at a pressure of 7,000 psi, in that case, you want to have a wireline pressure equipment that is rated to 10,000 psi with a safety factor. Something if you are anticipating that you will encounter 10,000 psi of pressure in the well, then your wireline equipment needs to be rated to 15,000 psi. Now, these are the three common pressure ratings that are present in the wireline equipment. But as we are going deeper, we are going into high pressure reservoirs. Wells can contain 20,000 psi, 30,000 psi. So for that, the equipment is being developed as well. So with this, I come to my conclusion presentation. Let's quickly revisit what we learned in the wireline technology. The wireline technology was first developed by Conrad and Marcel Schlumberger back in 1920s. They used electrical resistivity tool to determine the reservoir properties, and from there, the whole business and whole technology of the wireline flourished. The wireline logs are used to measure the well, the formation properties in the well through the electrical lines. The wireline logs are constant downhole measurements that are sent through a wireline to help the geologists, drillers, and engineers to make real-time decisions about the drilling operations. The wireline operations can measure the resistivity of the formation, they can measure the conductivity of the formation, they can determine formation pressure, they can determine the sonic properties as well as wellbore dimensions. That means how big your wellbore is and how deep your wellbore is. The wireline tools are very specialized, highly complicated tools that are lowered into the wellbore, and they are located at the end of the wireline cables. These tools can make different type of measurements, and we have talked about different type of measurements before as well. And all of these tools have have a particular operation to perform. They can either perform the evaluation of the rock properties, they can determine the location of the casing collars, they can determine the formation pressure, and they can also give you information about the porosity of the formation. With this, I conclude my presentations. We can take some questions now.
Thank you very, very much, Syed Hassaan Ali. Ladies and gentlemen, we all can appreciate the level of expertise that our presenter has. We are talking about a field with a lot of highly technical terms, and the fluidity, the flow of information that we had from our presenter has proved to be very, very impressive. Thank you very much, Hassan. You've done a superb job, and the entire family of Atlantic International University is thoroughly grateful to you for that performance. So it is our time right now, ladies and gentlemen. We can grab the floor to ask the questions we want to either share with other participants or know about a little extra when it comes to wireline technology applied to the field of mechanical engineering, or very specifically and gas industry. The first question is coming from Stelio Sambani. Go ahead, Stelio. I just unmuted your microphone.
Yes, hello, good afternoon, everyone. Good afternoon, good morning,
Hi.
everyone. Hi.
Hello.
Okay, yes. My question is regarding about the logging cable, the cable. I would like to know that which size are common of which size of the cable are common to use in this system, and how we know that size is adequate for the system, and we have is end relation between the flow and the dimension of the cable. Sorry.
Thank you, Stelio. So
Okay.
to determine that, so the different cable sizes are very specific to the wireline companies as well. Different companies will have different wireline cable sizes. Essentially, the cable size is determined by two factors, two big factors. One of them is the safe working load of the cable. That means how much uh, weight are you going to hang at the end of that cable, and how much deep it needs to go, right? So usually you have a thicker cable for deep well or deep subsea operations, and you have thinner cable for land or onshore operations where their depths are not as deep as uh, subsea operations. So the safe working load of the cable is very important. So that one thing which you need to determine is what is the weight of the tool that you are going to hang at the end of the cable. The other one is the restriction. For example, in the production logging operations, you need to determine what is your tubing size, because the tubing size will determine if you can pass that particular tool through that tubing or not. And that particular tool will determine what is the size of the cable that you need to select. So multiple factors are available, are present that you need to evaluate before you can make a decision about the size of the cable.
Thank you very much, Hassan. The second question is from Cece Jules Haba. The floor is yours, Cece.
Okay, thank you very much. My question is already in the chat box. What factor depend the quality of oil and gas during the hauling and production process? And what are environment impact of the industry during this extraction? By
Thank
the way,
you.
finally, what
Thank
can
you.
be the difference?
Let's look at just the first question
Okay.
to give time to Hassan to process your question. Thank you, Cece.
Yeah, thank you.
So if I understand the first part of your question correctly, the properties of oil and gas. So the wireline, if we talk about that in the context of the wireline technology, right? Through the wireline technology, you are trying to determine few things. Number one is you are trying to determine what is the pressure downhole. Okay, what is your formation pressure? Second thing we are trying to determine is where your oil and gas is located. So at what depth you need to go, at what depth you need to have your production tubing deployed. Second thing you are trying to determine is the porosity of the formation, right? As I said, there are two types of porosities. One is effective porosity and the other one is ineffective porosity. So you are trying to determine how porous your reservoir is, because the more porous your reservoir is, more oil and gas it is going to hold, right? So these are the few factors that you are trying to determine: pressure, your porosity, your temperature, and your depth, where your reservoir is located.
Perfect. Chimi Yunis, we are giving you an opportunity now. Chimi Yunis, go ahead, please.
Thank you, sir. Actually, maybe I would have some disruptive interaction here because I was late, but I have been able to capture a little bit of what the wireline technology is. But I would like the lecturer to kindly help me out to understand if the wireline technology is geared only towards oil and gas. How does that help us to manage the environment?
Okay, do you get that, Hassan?
Yes, I did. So one of the things which I want to clarify over here is that although it started as a service to the oil and gas industry, it's not just concentrated to the oil and gas industry. We are using now Wireline technology to determine. So there is another thing which is coming up, and this is very environmentally important, which is called carbon capture and sequestration. Entirely different topic. Effectively, to explain it in the simplest terms, the companies are now developing technologies to capture carbon dioxide from the air and store it in the earth. So you are removing carbon dioxide from the air and storing it in the earth. Wireline technologies is a crucial part of that whole puzzle, because wireline technology is determining what formations can actually store carbon dioxide in the earth. So we are using wireline technology to find those formations. We are trying to find those reservoirs which can hold that carbon dioxide. So environmentally, wireline technology has a very important place and a very important role to play.
All right.
Yeah.
I'm not sure whether Augusto Lati is still available in the among the participants. He is referring to this condition. I don't know if you mentioned only one condition, so his question might make sense if there was only one condition. So here is the question for you, Hassan Ali. When drilling in this condition, can that be called directional drilling? Let me see.
Okay. So that's no. So directional drilling is entirely different topic. Wireline technology does not have much to do with the directional drilling. However, some of the technologies, some of the physics that is used in the wireline technology is also used in the directional drilling. Particularly, not just directional drilling. There is another concept which runs in parallel to the wireline technology, which is called MWD, LWD, which is logging while drilling, measurement while drilling. Very much similar to the wireline operation, but there are some fundamental differences. So the physics that is used in the wireline is also used in the MWD, LWD operations. The tools are different.
It looks like Chimi Yunis has another question, so I don't see other hands up. So we will afford you the opportunity to ask the second question. Chimi, about CO2, right?
Yes, I love to the chart. I wanted to know, he said we trap carbon dioxide. I wanted to know when we trap it, how do we use it? I know it definitely controls um um what do we call that heating, but then when we store it in the earth, what next? What do we do with that?
So primarily we are just using it for storage. So the companies are, so there is this effort by the different organizations, by different companies, by the governments themselves to have carbon neutral technologies, right? Or effectively trying to remove carbon dioxide, so we have less of the carbon curve going into 2050. So when we are removing that carbon dioxide, we are storing it in the reservoirs. Effectively, this is just storage. We are removing it from the atmosphere, we are just storing it.
And you too, Cece Jules, have another question? Cece?
So, what are the environment impact of the industry during this extraction? And by the way, what can be the difference point between the ground hole wiring and the marine process?
Is that clear enough for you, Hassaan?
No, Sisi, can you actually repeat your question?
Can you be
I say
very, very specific,
yeah,
Cece?
the environment impacts of the industry during the
Okay.
extraction phase.
Okay.
And the
We got
difference
it.
between the ground hole wiring
Remember,
and the
one question at a
marine
time,
process.
the environmental impacts.
Yes, environmental
Go
impact.
ahead, Hassan.
Okay, so the environmental impacts of the operation. So the industry have come up a long way. There are more regulations. There are not only just industry regulations, there are governmental regulations as well, which actually determines what you can do, what you cannot do. Effectively, when I was talking about the pressure containing or the pressure, uh, actually this slide, let me just go back to that. The pressure control during the wireline operations. This actually stems from all the lessons that we have learned from different disasters, different environmental issues that the industry had in the previous years. And the pressure control is very important because if we lose pressure control, and we have a lot of equipment that is just there to ensure that the well barrier integrity is not compromised. It is to ensure that there is no uncontrolled exposure of the hydrocarbons to the environment, because when it happens, it does not happen. Uh, it has very bad environmental impact. We cannot deny that, right? So pressure control equipment, rating of the equipment, different type of technologies to ensure that the wellbore fluid which actually stay in the wellbore, it does not go into the environment. It's huge and it's paramount. That's why I had a slide over there to ensure that we are aware of the environmental impacts of the operation as well. The industry has come up a long way. The emissions have gone less. The wireline units have become more sustainable. The other now the question can be, because of the seismic operations or because of the drilling operations, there can be environmental impacts, and I'm not going to deny that, because the technology has been constantly evolving to ensure that there is no environmental impact. And now the environmental impact are very, very minimal. But yes, when the industry first started, when it was still in its nascent stages, there were environmental impacts to that.
Impressive. Right to the point, very clearly and in a very concise manner, as required in the world of academics. Olufemi Oluleye, go ahead.
Thank you very much. Yeah, good morning. I'm grateful to Professor Syed Hassaan A for excellent presentation. Please, I have 3 questions. I don't know.
I'm so sorry. I'm so sorry.
Time.
I'm so sorry, Olufemi. We've got to take just one at a time, because we need the presenter to understand and be able to process your question before we hit another one if we have the time. Just please,
Okay.
one question
Okay.
at this time. Thank you.
Okay, sir. Thank you very much. Okay, the
Well,
first question. Now, from the triple combo, which means that 3 tools can be run at the same time. So that helps to save time. It helps to save time. So instead of running a tool singly, that is running at 3 times, now we can run only 1 time, running 3 tools. So my question is, can we assemble more than 3 tools? Or how many? What is the maximum tools that can be assembled together in order to save lead time? That's my first question, sir.
thank you.
Thank you, Olufemi. So that's a very interesting question, and thank you for asking that question. So, in my experience, the maximum I have seen in most of the common operations is what we call a triple combo, the 3 tools that we run together. The reason for that triple combo is there are a few factors. The number one is each tool has its weight, right? And you have just one wireline cable that is being run from the top to the surface, from the surface to the bottom, right? So imagine the weight of that tool on that cable and entire length of the cable, right? So the combined weight of the tools should be within the safe working load of the cable. That is one thing. The second thing is that there is a lot of data that is going through that cable, right? All of these 3 tools are sending and receiving data from the surface. The cable can only transmit certain amount of data. It cannot transmit more than that. So what we have seen in the industry, and there might be operations that I'm not aware of where they are running more than 3 tools, but in most of the common operations, we see that the cable is saturated with the amount of data that is going through with 3 tools. After that, you have to run more than one cable, and that does not become a wireline operation. That becomes something else.
Let's see if we can take your second question, Olufemi.
You're still muted, Olufemi.
Can you hear me?
Yes, go ahead. Straight to the
Okay,
question, please.
my second question goes thus. Now, with the development or advancement in technology, is it not possible for us to have a multi-purpose tool that can just be run once and send all the signals from the formation? So that's my second question, sir.
All right.
Thank you. So this actually brings to another set of technology that we were talking about earlier. I think there was one question about it, which is called LWD, MWD, which is called logging while drilling, measurement while drilling. So effectively the same, or not the same, I will take my words back. The similar tools that are used in the wireline operation can be also used as part of the drilling operation to make your measurements while you are drilling. So you don't have to run a wireline log separately.
All right.
And
I'm sorry.
yeah, and to some extent, in some of the drilling operations, in some of the clients, they have completely eliminated wireline logs. So they have completely transformed to LWD, MWD operations.
Okay. Ladies and gentlemen, we don't want to cheat you out of opportunities to voice or raise your own questions, but since I don't see any other hand up, and we are running out of time at this moment, so that's why we're going back to Olufemi for his third question. Go ahead, Olufemi.
Thank you very much, sir. Can you hear me, sir?
Yes, yes.
Okay, my third question goes thus. With the technological advancement that NASA, that is North American Space Agency, can send space craft and to get information. What is the industry doing, particularly referring to seismic operations, that we cannot have seismic tools that can be run, and they, right from the surface, they give us all the information we need that will obviate the need for even drilling, for obviate the need for drilling operations. Thank you, sir.
Thank you, Olufemi. So the seismic operation, the amount of data that you get is limited, right? It's just giving you returns from the formation. Now, you still need to do testing. You still need to do wireline logs to determine how much oil and gas is present. Seismic operation can give you an idea about there is something downhole. It cannot tell you how much. It cannot tell you how big. It cannot tell you how deep. It can just tell you there is. What seismic operation is telling you is that there is a certain type of rock formation downhole that can trap oil and gas. Whether there is oil and gas present over there, whether that formation is holding anything, it does not tell you that. It just tells you that there is something downhole which can hold that porosity levels.